Alright, hey everyone. We're looking at the function faces project. Kind of want to give you a quick lowdown of some of the things that your calculator can do and how you'll be able to use it to create a cool little image that looks something like that. Um, just for a quick example, you can see here some of the faces that were made in the past. Stewie, uh, Hello Kitty, all those got really good points, but you could go really basic with one of these generic smiley faces as well and get uh, maybe not the bonus points that could be put into it, but definitely can get some solid uh, completing all of your project requirements. Basically, here's what we're looking at. You have to be able to fit in these specific ground rules, which is basically it needs to have a face. It needs to be eyes, nose, mouth, etc. But it could be more than that. It could be an entire body. It could be something with background images, like a scenery. Whatever you do, once you get rolling with it, it's really difficult to start, but once you get rolling with it, it's pretty straightforward. And that's about it. Just to be creative, you need to have at least 20 functions in it. So basically, you have these sheets which match if you go on your calculator and turn your calculator on and go to the y equals button. You're going to do a lot up here with y equals. These y1 through 10 all match what you have on your calculator of y1 through y10. So what you're going to do is you're going to put in a various function. So say, I don't know, x squared plus 1 would be your first function. And that will be your equation. Part of image, that's just for your benefit when you graph it. Like, oh, hey, this is going to turn into be part of my mouth, for example. That's what you would put there. And then this graph on here is just for you to try to help graph it all out. You got a couple of pages of that. And then this last page, if you want to print this out to draw out ahead of time, um, how it's going to look, that might be a decent way to go about it. That's how I made my Nittany Lion that we saw here on this front page. So, just to look at a couple things, you type in an equation. If you hit graph, to make sure, first off, the first time you should do it, hit zoom 6, zoom standard. That should make sure that you have your standard window, because if this window is messed up, you could have something that looks, well, helps if I do it correctly, something that could be way offline. So maybe it was from 10 to 100 by accident. It would look something like this, which obviously doesn't do us any good. So make sure you're first in the standard window. And let's just for fun add another equation. Let's add log of x. So here's just a couple of equations that I have to begin with. All I have to do is to go back and forth between y equals and graph, and you should be able to get your picture to show up. Okay? Now, the idea is, for an example, this quadratic could look a lot like a mouth. The issue is, I don't want the mouth to go all the way up through the top of my head. So, what I can do is, if you look at limit your domain right here, you can find a way to change and basically stop your function by altering the domain. So what it says to do is put the entire function in parentheses. So if I can retype parenthesis x squared plus 1, you can also use the insert function, which is second delete, to put in parentheses. And then if you divide by some domain restriction, so for example, they're using this one right here, the x is less than 2. So the way I do that, I put that denominator also in parentheses. Very important. The x button again, right by alpha here. Less than. To get to any of those less thans, it says right here, use second math logic. So second math, go over to logic maybe. First though, right here, all I care about is x is less than, so I go down, equals, less than 2. Then if I go back to graph, it'll regraph the entire thing for me. And look what it does. It only graphed that x squared function stopping at x equals 2, only something that is less than 2. Well, that's great, but what if I want something... Oh, I need to cut off over here then as well. Something that is maybe bigger than, say, negative 2. Well, that's where we use that logic statement. So if I go back to it, and I'm going to hit second math logic, not only do I want x to be less than 2, but I also want x to be bigger than, so greater than, say, negative 2. And what that should be able to do is to give us that big quadratic equation. We cut it down so it only goes between negative 2 and positive 2. So that's an idea of a way to make a smile. And remember, use your ideas of functions, okay? Maybe I want that smile to be a lot taller, or I want it to be a skinnier smile. I can put a number out in front. That should make a vertical stretch, so it should look like it goes up a lot quicker. Maybe I don't want it at +1. Maybe I want it to be further down, so I'll have a, instead of +1, maybe -4, and that should shift it down instead. And there it is. Okay, so using all these parent function ideas that we've used throughout the course of the year. Now, once you get all 10 of your functions filled in, let me put in another one just for the fun of it. Let's say I want to do the square root. That's, you hit second there. Let's say the square root of x plus 3, just for fun, and so you can see what one of these looks like. Let's do sine of x. Get those to graph as well. There's a square root. There's a sine. What I'm going to do now, first off, this very first thing, before you save a picture, you must make sure your axes are off. So follow this step where it says second zoom. Zoom is up here at the top. And you want to go down and turn these axes off. Hit graph again. Now it doesn't have the X and Y axis on there. It has just your image. So right now it looks like I have two random whiskers going around a tall nose with a squiggle in the middle. Cool. To save that image, follow this step right here where it says save image. So we go second, program, go over to stow. What we're going to do is we're going to store pic. Now it asks you for basically a value. This is like your image number. So I'm just going to start with image 1. And you hit enter, and it's now saved your picture. Okay? Now, later on, you may realize, oh, I made a mistake. I needed this squiggly line to go down or something. What you should do as well is go to second program and also store the equations. That's store GDB right here. And keep it as the exact same number. Store GDB1. It'll say it's done. So what that means is now, for example, I could go back, clear all of these out. If I hit graph, well, nothing's graphed, obviously. However, I can bring that image back up. Right here it says second program, and we're going to recall pic. We want to bring back picture number 1. And look, there's your picture. Even though I don't have any equations written, I have the picture that I had to begin with. And what that means, though, is once you have that, you need 20 functions. You can only draw 10 at a time. So once you draw your first 10, now you can bring on, okay, number 11. Well, hey, I want another squiggly line, which was sine of x, but I want it to be a lot lower. So it'll take the picture you already had and add on your squiggle. Okay? Maybe I want to add another one, but at negative... Well, I have one at 8. Let me do another one at sine of x minus 7 this time. And I hit graph. Oh no, what happened to my picture? Now it's only graphing the 2 functions I just put in my equations. You can always go back, second program, to recall picture number 1, and it'll bring it right back. Okay? So that's how you can bring your pictures and all that. And again, same thing, if you realize you made a mistake on your original, you can always recall your original equation, recall GDB1. Thing is, though, those 2 sine graphs I just did, they're now gone. All I have is the original graph. So make sure that you only do this if you have everything saved. Only do that if you need to go and change one specific thing. And then again, make sure after you do that, you would go back and save it again. So I need to make that one little change. And yes, it's always going to regraph everything one little step at a time. So make sure you are aware of that. Couple other little things you can do as you're graphing things. Hey, I know this first equation is correct. I don't need to look at it anymore. If I go on where that equal sign is and I hit the enter button, it's bolded. That means it's going to graph right now. It's not bolded, means it's not going to graph. Y5, Y6, they're not going to graph because there is no graph. Okay? I can do that. Maybe let's say I'm taking those two out. Those equations are still there, but it's not going to waste the time to graph it right now. So that might be a way for you to save some time as you're messing around so it doesn't graph the same thing over and over and over again. Because then I can go back and add them in later. But a couple of things to look at, maybe for example, see how close this last graph I just did was, how close it is to that sine curve. Maybe I want it to hit exactly at that spot. Well, I need to shift it up a little bit. Well, shifting up means that I need to increase it. So let's say increase by 1. So it's going to graph everything. Does it match now with where my sine graph is? Well, I got to wait for it to graph. And hey, look, it looks like it matches perfectly. Maybe it's not quite where I want it to be. Maybe it just is a little bit higher. You may need to go even into some decimals, 1.2. It'll be really precise on some of these, so make sure you're messing with it, and make sure you're saving your images early and often. That's why I gave you the sheets on here to write them down. Definitely write them down, because you would be surprised how many times you go back and you accidentally, instead of hitting delete, you hit clear. Oh no, it's all gone. What did I have? If you have it written down already, you can go and type right back in what your equation was. So I highly recommend writing that down so that you have them all there. Okay? And then what you can always do at the end of this, right here, if you don't remember what picture you were on, so like store pick, we said this is store pick 1. If you forget, this memory management allows you to see which ones you saved already. So second, the plus sign. If you go down to memory management, you can see down on pictures, which is number 8, you can see that, hey, you've saved one picture, picture number 1, so the next one I should make should be picture number 2. Another little trick you can do. Once it's all done, you'll combine them all together, and I'll show you how to send it to me. But at this time, just get going with it. Start thinking what you're going to do. And the last thing I would recommend, especially if you're doing just a generic face, is what is the equation for a circle. The equation is x squared plus y squared equals the radius squared. These are all functions, though. So you definitely cannot just type in x squared plus y squared equals radius squared. You have to figure out how to get y by itself, and I'll leave that as a challenge to you to see if you can get a circle to show up. Best of luck. Have fun with this.